All right, hey everybody. We're still working on microphones, but I'm going to start this introduction. Welcome to the closing panel that is starting now. We had to bring chairs in from the other room, so hopefully you had enough time to get food. There's still food back there. There's drinks. There's bathrooms out in the hall. But we're going to be running this closing panel. It's a discussion full of your questions. Yeah, throw all the vegetables you want at that. And the theme is going to be the future of HBase. All of these questions, you guys, please go on your phones, go on your laptops, go to slido.com and the code HBaseCon so you can vote on these questions. You can submit more questions. I put some questions in that were interesting to me personally, but if y'all have different questions that you want to hear our esteemed panelists talk about, then we can adjust.
Yes,
and
we're telling you to use your cell phones. Get them out and use your cell phones. This is the first time all day you've been enabled to actually and encouraged to use them.
Yeah. And if you ask really bad questions, then I will use moderator power to make them disappear. So don't even try it. I had bios from some of my panelists, but I'm going to let them introduce themselves because I only had bios from some of them. So Josh, if you can say a few words about yourself.
That's better than the alternative I thought was coming for me there. So I am the engineering manager for HBase in Phoenix at Hortonworks.
That's enough words.
And yeah, that's good.
You will. You'll hear plenty more from Josh. Somebody else?
I'm Clay Baenziger. I'm an architect for our Hadoop infrastructure team at Bloomberg. So responsible for HBase Phoenix as well as Spark Yarn, HDFS, Kafka, kind of all the allied technologies there, running it as a general purpose service for all application teams at Bloomberg.
Hi, I'm John Leach. I'm a co-founder of Splice Machine. We basically built a relational database on top of HBase, so that's kind of my background, and definitely very passionate about storage.
I'm Lars. I have the same job I had this morning. I run HBase and Phoenix at Salesforce in terms of development and also running the service.
And I'm Mike. I didn't actually introduce myself. I'm a HBase developer at Cloudera. So we have questions. Yeah, we have questions. I'm going to start off with the question that's I like. It's the top one up there, but it's not the one that has the most votes. But like I said, moderator privileges have. Hey, vote, and then we'll get your questions up there. How do I? Oh, there we go. Okay. You guys don't, that screen's actually not on. So I'll read the question for you. How do you see computing having changed since the original big table paper? We're like 10 years in, 12 years into doing this HBase thing. What's different now? What assumptions and what decisions are no longer valid? Anybody can jump in on this.
Yeah, I can start. So I see it. The main things that have changed are the networks being much faster. Right. So as I mentioned this morning, data locality no longer matters. Only cache locality. That's one thing. And obviously, the other machines have become much bigger. There's much more RAM, so there's much more caching. Yeah, that's all I have to say to that.
I'd say, yeah, we see networks are probably 40x their size from 2006, 1 gigabit to 40 gigabit. Disks have gone from maybe 15K fiber channel if you were paying a ton of money in 06 to NVMe disks that do 2 gigabytes a second. CPUs, no manufacturers really had 50 core machines back then. Now we see dual die 50 core machines being pretty common on-prem or certainly clouds. Similarly, I'd say we're probably more polyglot than we were back then. Java certainly was a very strong enterprise language. Now we see Rust, Go, .NET, Java, Python, C++ still lingering around.
Yeah, I would agree with Lars around, especially around cache locality in the CPU. And that leads what you've seen as an adoption of schema. So when we first started, it was a key value, and you threw some bytes in. And no longer we're just throwing bytes in. We realize like we have to get those bytes out somehow, and it's got to be really efficient. So I would agree with you really on the cache locality schema. And then the other thing that's changed, at least from my way of thinking, big table is all about cap, and you're looking at consistency over availability. And I think the reality is in the database community, there's no longer I'm this, I'm that. You have basically planes where you may be consistent and partitioned in one plane, you may be available and partitioned in another. And I know Apple and Bloomberg had a talk talking about availability. That's an example of where they're starting to switch to these multiple planes simultaneous, and then using some kind of magic logic on top to understand which plane to look at, in what situation is it okay to be a few seconds late in the data. So I think that's one of the things that's a little different.
Okay. Thanks, guys. One more?
Yeah, one brief thing is the larger RAM sizes we have now, right? Where back then it was fine to put everything on the Java heap, right? At least with HBase, not with Bigtable, and that is definitely no longer the case. And hence we have all these efforts now, off heap cache with bucket cache, or running multiple HBases, region servers on the same server, or making everything virtual. That just becomes much more important these days with the large RAM sizes.
Actually, one more just kind of key technologies we probably go through more questions to think about is persistent memory too coming up. The concept that I can actually have some just byte addressable normal memory structure that rehydrates when I've rebooted the machine has vastly changed the way to think about things like write-ahead logs and other tiered hierarchies of storage.
So we can just go home and rewrite everything, right?
All right, I'm going to stop you guys there on that question, because I think this next one is actually really interesting too, and it wasn't asked by me. What threats do you guys see for the future of HBase? It's like a super open question, and it kind of plays off of looking at the past, but looking, what's going to be different in 10 years? What assumptions do we have now, and what threats? Anybody want to jump on that?
4 letters, HDFS. and the fact that we don't replicate at the HBase level, which leads to fairly low or lower than we would like availability at the HBase level. I think those are the threats on my mind.
I want to definitely talk about some more like how do we do more at the software layer inside of HBase. I definitely agree with you on the point of a need to fundamentally redesign some of these core components inside of HBase itself. I think we've kind of shifted now where consensus protocols, like we have the tools and software, they're not niche anymore. Like they're mainstream enough. I think it's really the time and effort they're just missing right now. But it's interesting because I had a completely different take than what Lars had. I think this is the interesting part now because a brand new question here. We're thinking on the fly now. But my take is actually much more just. I think the thing that could come and kill HBase would actually be something that I think Misty was the one who mentioned it today. She's like, we're no better off in auto scaling and auto configuring than we were a year ago. And that was like I think that's something so really the thing I would be worried about most is really usability. I think if someone really put their time and effort into saying, how do I get a distributed system, just any database that scales and just runs for you and removes the operator pain, I think appealing to the human laziness, I think that's the biggest threat to HBase.
One that I see just talking to people out there is kind of an interesting one. So people are trying to move to private clouds, public clouds, and their question is like, how do you do that with HBase? And specifically, if you look at like the platform companies, they were very much focused on the management of Hadoop HDFS, things like that. As you move to the cloud, that's less of, they're no longer the dominant players when you move to the cloud. You're talking about a Kubernetes, Mesos, these other sort of scheduling sort of architectures that someone like Clay would try to blow this thing out with. So it's interesting. That was the part that caught me by surprise. Like when we did our cloud service, realizing, wow, this is easy, but there's nothing in the HBase community that's been pushed out to say, hey, look, here's how you stand up in a DCOS cluster HBase. How do you do this? How do you auto-scale it? How do you do these things? And we're still stuck in a non-container, non-scheduled, non-resource managed world, and everybody else is moving as fast as possible there. So that's one for me, if we could have a really nice way of doing that, open source it, get a lot of feedback from operationally running it. But I think that's something I think that is a real threat to us because, ultimately, I think most people are going to be moving to these cloud environments. They just make economic sense.
Yeah, I totally agree. That's what I mentioned this morning as well, right? Why doesn't the HBase ship with things that makes it easy to run it on Kubernetes, to run it on AWS, GCP, and so on, right? So we should, some of us here, maybe needs more than one, but a few people should do this and make it part of HBase.
Yeah, I think there's some interesting challenges here with both just the awareness of HBase, to be able to make it easy to run on cloud infrastructure. There's got to be an explanation of how to do that, and we've got a lot of very awesome features in HBase that don't get that awareness. So ranging from a very easy test for, say, hey, I've got a Kubernetes test environment. Well, we've had Java, mini test clusters in the Hadoop ecosystem for, I guess, over a decade at this point, probably. But awareness of how do I stand that up in a Docker image so I can test it, and then trying to make it so that it's a full stack HBase. How do I actually get multiple region servers to stand up trivially in a Docker environment with all batteries included, so that it's not production scale, but it's easy to use. And I think that then ties into what is a killer with regards to kind of just competitors out there like SQL. We've got Phoenix now, which is awesome. But there are definitely very mature SQL databases that are figuring out how to shard, scale, and distribute and replicate in impressive ways. So I think we need to figure out how do we tackle these things in a combined effort.
So I think let's focus in on some of the things that you guys have said. And Lars, this might be a question really for you based on that claim you made this morning. What are the implications, both good and bad, of separating the storage from the compute or the stateless? Like if we aren't so coupled to HDFS, if data locality really doesn't matter perhaps, what does that really mean? Like you can make the claim, but I'm going to ask you to back it up.
Okay. The claim I will make here is that it mostly makes HBase easier to run, right? So imagine we didn't have to run HDFS, quorum journals, all this stuff, the name nodes, dealing with the failover, all this shit we have to deal with all day long, right? Which, I mean, it works well enough, but you can see it's falling behind of what it should be, right? And what if we run fewer of those and manage them in a stateful way, which is, it's always harder to manage stuff with state on it. Data has a mass, right? So it will resist movement. So it costs you force to move data around, right? HBase doesn't have any mass by itself, right? It just looks data up in HDFS, right? So what if so the first step is to separate the two and run the things with mass carefully and run the stuff without mass in a more ad hoc way, in an auto-scaling way, right? So I can just dial, at least in theory, the number of region servers up and down fairly easily. There's some things we have to do with write ahead log and so on, but in theory, that can work. So that's one thing, right? Then what do we do in the cloud, right? So in the cloud, we already have the S3. We have to, I forget now what the Google equivalent is called. Do you guys know? Anyway.
Google Cloud Store.
Google Cloud Store, okay. GCS. Okay, good. Never mind. And so, what if we pick a standard interface? Let's call it S3, and then run HBase over S3 over HDFS, and then we can do that on-prem in our own data centers. If we want to, we can. I'm sure have a very thin layer that that is over GCS, right? And it will run just on S3 and AWS, or pick any one thing and say that's our abstraction layer. And yeah.
I think one key thing too is not to set HDFS up as the daemon. I remember 5 years ago running HBase off of CephFS, for example, which worked fine. It provided Hadoop compatible file system semantics, just great enough that you could run HBase at the time on it. But I think the key part is that we have to re-envision storage for HBase. And I think that's a key advantage that we have as a community versus if you are hopefully no one minds me naming names, but like a Postgres, where you assume you're writing to local disks, or a Cassandra, where you assume you're writing to local disks. We already assume we're writing to a network storage interface. Let's re-envision what that network storage interface looks like more broadly.
I think that's sort of the point. So what the thing I almost want to jab you about, I think maybe the fault was that we picking one would be the problem. We'd be falling into the same hole we fell into once. I think we actually have a very clear understanding of what we actually need from each component set of HBase. I think we actually know very well. It's not that we have a lot of mass in HBase. I think we have a lot of baggage. I think, and the way to fix that would actually be, I think, maybe turn it inside out from HBase and say, from our point of view, instead of choosing one and doing it, and then sticking and implementing to there, maybe the right way to go about it instead would be defining what HBase actually needs and then seeing what we can plug into that.
Yes, or picking up on what you said as well, right? So why can't the HBase, every region server just always writes the local disk, and we handle the replication at that level, and we have HBase is the file system as well, right? That's always the contrarian I am. They can go both ways. Yes.
Yeah. So one thing I keep an eye on is AWS and how their databases are writing. And one of the things, they have a new Postgres implementation. And one of the things they added, because of the latency for storage that's remote, like an S3, they started doing walls as rings. So you would write your first wall entry and you kind of ring around. So you're not, like right now in HBase, for example, you're writing, you're blocked until the next thing. Well, they wrote it in a ring. They have the sequence, so it's kind of like an LSM when you recover, I guess, from the write-ahead log. Sounds simple, but it was an example of how they kept storage remote, not local. They're writing to a distributed file system. But they changed the application to understand that there's going to be increased latency. So you have to reimagine what a write-ahead log looks like. To be honest, we probably should have done that initially, especially with SSDs and other things. We have the ability to do a lot of concurrent writes. So that was one. When I look at it, you almost have to re-envision the sticking points. And for me, it's like the write-ahead log is definitely a sticking point. And I don't know if anybody can jump out, but when you have the stateless compute, I guess the biggest one would be your write-ahead log, unless I'm missing something. And you hope that you get enough in your cache that you can be performant.
Well, just it's our most opinionated write process, I think, right now, is the write-ahead log.
It's our throughput bottleneck. So, we do everything from batching to region serve. We'll batch every put to every region onto a region server. We do all this kind of stuff to try to get it through. But ultimately, we are all, whether it's TPCC or bulk loading data, we're always bound by that write-ahead log. And when you look at what AWS did, it's a novel approach, but it's something where we can look at a best practice, something that worked, and just kind of move forward with that. That would, to me, that write-ahead log, doing it in a ring, knowing that you're going to have a lot of concurrent write throughput to a distributed file system, take advantage of that and roll with it.
Yeah. Or everything like Bookkeeper and have a write-ahead log per region, right? And in the special things we use, in the write-ahead log is not just a the small writing of like very small things. We use it, at least we used to use it for for region server fencing, right? We remove that server's directory out of the way, and because that happens to be atomic in HDFS, it's a nice fencing mechanism, right? So anything else we're going to use, it's not going to work that way, right? So that's things we also have to invent at some point.
I think we have another really interesting question here, slightly related to the write-ahead logs being a huge bottleneck, I think, is also how do we architect HBase for true high availability? Where we can tolerate loss of a data center or an AZ or a region or possibly in the cloud, but like we have a lot of points of failure. What can we do to address those?
Yeah, I think some key parts about this is trying to pick what semantics we want to hold to. There's certainly questions about HBase. I always have seen as a strictly consistent data store, very close to. If we follow this philosophy, then looking at intra-region center within a intra-region replication as a strictly consistent function, and then thinking about how do we do spanning from regions consistently. There's certainly the wide world if we relax that assumption, but I think the challenge is getting from where we're at today to a meaningful state first before we'd ever propose further. And maybe I'm closed-minded with that, but I think within a data center or within a region, trying to be able to solve the issues that region replicas started us down, thinking about wall replication or memstore replication within different region servers, to being able to say, hey, we've got a quorum consistency at this point, and we've got a strictly consistent proposal system for being able to replicate data is one way to get us there. Now, how do we span that across availability zones or data centers starts to become an interesting question with latency and all that.
So one of the last talk, the two guys from China, from Xiaomi, they gave an interesting talk about the one feature they've been working on, which was serial replication, which is an interesting notion, but I think it hits on one of those important points that you noted, Clay, where it's you can't do it general purpose. You kind of, it's almost back to the capsule. You have to choose what you want to optimize for. And I think serial replication is a very interesting and it's a good feature to do, but it's definitely not general purpose, right? So I remember looking at it and they were talking about making updates to meta to track the wall sequence, and my initial thought was like, man, that's going to tank throughput. Like we're updating meta as we're doing writes to all these regions, but it's to that point. What are we truly wanting to optimize for? And I think that's going off your keynote, Lars, that's one of the things you have to sort of understand. What are you trying to solve there? And really, say, be very explicit up front. Like, this is the use cases we're trying to do. I think it's definitely interesting to start thinking about now. Can HBase inter-cluster replication be a synchronous thing? Can that available or highly available side be something of the past? Like, should it be? But I think it's definitely the intra-cluster side is also very interesting there, and I'm totally on board with you there as well. I think the way of the future there is really how do we do something where we manage our own destiny of edits flowing within one cluster.
Yeah, sorry. Just for me, it's if you can be very declarative about what it is you're guaranteeing. And I mean, the nice thing is, you're not out on an island, right? We have the computer science community. There's ways to do a consistent replication. There's different protocols. There's a whole host of really interesting innovations around that. I think the hardest part, at least for Splice, for our engineers, we'll start going and not realize, hey, just define what it is we're promising through this piece. And especially like with this, when you look at it from like a SQL language all the way down to the storage, there's a guarantee. It's serializability, or it's select for update, or it's read committed, whatever that is. That has to fall all the way down to the storage and what you're guaranteeing. but I think it's really doable. And I also think the computer science has settled on all those different pieces, which is nice. Like you're not trying to invent something. But I think one thing the community could do that would help is just enumerate those and say, hey, here's what we do, here's what we haven't done. There's a JIRA for that if you want to get cracking on it. But that's, I think, the most helpful part.
Josh, you were talking a little bit about the serial replication stuff. I want to touch on that in our next question. What does data movement look like on these cloud clusters? Like, it's very different than what data centers look like, and how do we need to consider that for HBase?
Yeah, I think that's one of those things that, as a project, so as a HBase as a project, there, I don't think that's one of those cases where we can draw a line in the sand and say this is exactly what we're providing. I think I've certainly seen with users coming in with HBase, there are high-level business level requirements that have vastly different implications. There are people who will say, in terms of an availability zone or a data center, I absolutely want to have my backup data center be available for reads no matter what if my primary goes down. I have seen cases where customers will come back or users will come back and say, I can absolutely not accept serving any stale data out of HBase. So I think that's one of those interesting things where it's, we kind of have to, instead of drawing the line and telling you exactly how to do it, I think we sort of need to acknowledge what are the exact cases that we do want to support and what can we legitimately support, in terms of actually, we tested this and made sure that it actually does work. Okay, I think that is, without a doubt, that's what people rely on HBase for. They trust, when we put out a release, they trust that we've done the diligence there. I think that, making that distinction, that definition, and putting weight behind it is what we need to do.
I think, Josh, you may have answered this question in a different direction, actually, than I interpreted Mike's question. I think you've got a very good point on the promises made by the HBase community, and John, I think you set this up well as well. Depending on how my write-ahead log is handled, can mean, is this a fully, I believe correctly, linearizable, SQL system, or is this system have less stable durability guarantees? And as we start to rethink the storage in HBase, that actually begs that question, because now, depending on if, to a proposal you'd put out HBase in the clouds, I think, Josh, if it is a Kafka write-ahead log versus an HDFS write-ahead log versus potentially a synchronous consistency protocol like Paxos or Raft write-ahead log, that changes the underlying semantics of the database, and that changes very much what I can expect from it. And I suspect, again, kind of to an evangelism standpoint, we have to say as a community, here's the parts that we're promising. Now that's not to say, not a threat to Splice Machine, but Splice Machine 2 might come along and say, look, we're going to fight React with this database now. And we actually see different semantics there. And yeah, you could probably build it that way, but that is not traditionally how this community is operated. Certainly at Bloomberg, we always prize consistency and high availability. So we would want to publish how we would see it going differently. But it's not to say it's not pluggable. Now, reading Mike's question differently, though, I might actually say data movement in non-traditional clusters. If I imagine a very disaggregated cluster, I might start to question, do my HBases, we've had a couple presentations today from, say, Salesforce and such. We at Bloomberg operate many clusters. LinkedIn, when they talked about Kafka, used to talk about a hierarchy and a replication process between Kafkas. And we start to see that at Bloomberg with a replication process between HBase, where I might have a source of truth followed by different application teams using that data in different ways. And if we start to envision data movement between these clusters, how can that transformation start to look if it's not an opinionated HDFS that runs co-located with that HDFS? We've had an explanation from Pinterest on how their data is backed up and potentially replicated. Well, can I put a transformer between that? And can that start to change how that data moves? Or can I start to have different analytical use cases on top of this data now that it doesn't have a direct I/O impact potentially on my HBase? I don't have answers. I just have more questions.
Does that interplay with spinning up additional HBase nodes if you're If you're getting in a burst workload or some kind of burst query demand, your data needs to accommodate that.
If we've disaggregated to the point that HBase is, it's not stateless, it is definitely depending on state, but it is no longer connected with the state. I don't see why not that we can't at this point start to say we have different region servers come up on demand for hot regions becoming a thing of the past if I can span my quorum consistency protocol to ensure synchronous consistency among those region servers. Why don't I have 5 region servers or 3 region servers handling the load of that hot region while the other ones might still be one region and yeah, failover takes longer. But I think the challenge is simplicity. How do we also keep that?
You'll get that patch up next week?
Of course, yeah.
Okay, awesome.
Don't mind the CS PhD. I might need to finish before then.
Oh, yeah.
Yeah. There was one short thing I just wanted to pick up on what John said earlier is that the replication, it needs to carry the semantics of your data store all the way down, right? And so if we talk about things like omit and stuff, it's not enough to replicate at the HBase level, because now we're talking about transactions, right? And so it's not even clear to me how we would do that, right? And because HBase, they might replicate at different speeds, right? So do you write a omit log into the write-ahead log of HBase and you ship it that way, right? So that's a question for you there later. And yeah, those are things we now have to think about as we add more and more stuff to HBase, or to Phoenix rather, via omit, and that's the problem you have to fight with, right? Splice machine.
Yeah, but I mean, so from our perspective, the transactional layer, we kind of were born with that. I mean, that's how we started as a company. So that's something that, as far as our replication strategy and how we move things around, we've got a very clear structure. I think it's harder when you start to have a non-durable, I don't know the right way to say this, when you start to look at, like, in some sense, if you look at like what Cockroach DB does, for example, that's exactly what we do at Splice Machine. That's what, and it's, as far as the structure, yeah, you're writing to a table, but if you're replicating the table, you have the replica of the transaction. It seems like I don't know, that's something I feel like we're pretty confident of, in our ability to handle the transactional piece. But also, like with OMID, the person who wrote the original OMID, Daniel from Yahoo, he was at Yahoo Research, he's with Splice. So, we're really comfortable on the transactional piece. Less so on, like when I hear data movement, the part that's bitten us as Splice Machine is always remember the economics, right? If it's on EBS, it's 10 times what it is if it's on S3. That was the one thing that, you can be perfect, but if you're really expensive, there's no love there. So that would just be one thing I would say where we kind of, I think, made some mistakes, where you're trying to be really performant and all these cool consistency guarantees. And when we talked about data movement, we got kicked on just not using a cheap medium for that.
Yeah, maybe it's really simple. Maybe you just replicate the commit table and make sure you have we have to sync up the transaction oracles as well, so that they will, yeah, maybe it's not hard.
All right. It's almost 7 o'clock. I want to get one more question in, this one that Busby asked actually just like a couple seconds ago, because I think it's a really interesting question. Hey. Did you ask the same question, Misty, and I missed it? Oh. No, Misty's question is way harder.
Yeah, that's the point. It's a panel.
Surely they can answer these hard questions.
Surely you can't be serious.
Yeah, they don't have enough alcohol for that. And at least I am going to still hang out in the bar downstairs or in the hotel. So like after this panel's over, feel free to ask more questions. I don't know if I can convince any of these guys to come with me, but I will continue moderating, not answering questions. Anyway, so all 4 of you, you're associated with some kind of SQL system built on HBase. maybe associated is a strong word, but can HBase afford to remain an agnostic byte storage engine? Or like, is there reason to specialize? Is specialize the word that I want to use? Yeah.
Flexibilize, I would call
Flexibilize.
it. I like that HBase is just a byte store. It's really good at that, right? But what it kind of lacks is how can we hook the data type, say, with Phoenix at a lower level and make use of it at the HBase level, right? So what you are doing with the ORC files, and so how can this be just a plug-in to HBase, right? And do it that way so that HBase may know about data types or not, but HBase itself doesn't worry about it.
Yeah, I would personally keep them separate conceptually. I mean, if you look even like an Oracle, they have a storage group, they have an execution, they have different groups for the different pieces. I think to ignore schema is a mistake for HBase or for anybody at this point. That's really where, like I said, optimization happens. So I think you're right. Have something where you write a killer, quick way to get columnar type data if you want to do analytics. Get yourself a nice pipeline into Spark that's optimized. I would put those in HBase from a storage perspective. And then, I think to the other question Busby had up there, I think, Spark would be the horse I would hitch onto, that execution engine. If you have a really nice connection, something that's really fast, gives great throughput, still consistent, I think that's a big deal. But yeah, I would keep, I would focus on just schema, speed, compression, your ability to get into some sort of pipeline quickly. That's really what HBase should be looking for, because most people, if you look at where we're going, it's not a key value, throw some bytes. People have some sort of schema. It could have structs, arrays, stuff like that, but they're wanting a different performance profile, a different storage profile, and I think if HBase focused on that, that would be a huge thing. Obviously, I'm touting myself because that's what I'm interested in, but I just think it could be a real differentiator for the community.
John, to your point, do you see this being a requirement of the project, though, to adopt such semantics, or do you see this as a question of evangelism or best practices, or in your case, a vendor, potentially, being able to set up different patterns here? Because I see the value in HBase, and certainly the dynamics in the HBase community, while I've been so happy to be able to participate, has been the flexibility of the engine. And I don't know that there is a requirement for a strong coupling so much as a support for direction to be aware of in the community, such as the ORC support and things like that, to be able to be possible, but not necessarily a requirement.
I think, can I interrupt you? That builds nicely on what I wanted to yak about. I take a different stance than what Lars took on it. I think it's a very healthy thing to listen to what the people downstream are doing. I think you're absolutely right that there are performance benefits to be gained by having an application level or data type centric knowledge about the type of workloads we want to support running on top of HBase. But I actually think there is a lot of significant value. Like a good program manager, I learned, is really one who will say no. I think, that is the point. You can't accept every single feature request that comes into you. And in that respect, I actually really like HBase's, I use the word obstinance, but it's not the connotation I wanted to carry with it. Right. I think it's very healthy as a project, HBase is very slow moving in saying, no, we don't do, we store bytes and we will give you bytes. Because that focuses us, that gives us that laser precision to say, this is exactly the use cases we are performing, and we would do them damn well. And that gives us good focus. But I think at the same time, it's also very healthy on the other side of the coin to say, if people are using it this way, how can we take those high-level requirements and really say, what makes sense to optimize inside of HBase? How do we take these things and build something that is really effective at the HBase level that these downstream components can really leverage to help them give the things that they really want?
So I wasn't saying no, I was saying make it pluggable and flexible, right? And so there's a lot of, in that one statement, right? Because the HBase has, above the storage, there's this whole scanner layer, right? And that scanner layer assumes bytes everywhere. It assumes that on your way up, you build your row together out of the key values, right? So a lot of the work we could be doing, or we should be doing, with having columnar storage in HBase with data types is then more or less invalidated by by all the layers on top of it, right? And so if I say pluggable, that means this whole thing would have to be plugged or changeable or more flexible to do that, right? So I think we're saying the same things with different words. So
But don't- Just one thing, I mean, you realize, like, if you're just returning a row or two, the current HBase is fine for that. The question is when you want to vectorize for like a large analytical piece. That you can write on the side. I think we could write something into HBase that says, look, here's how you read store files directly from HDFS. That's what we did a splice, but you just generalize it. Say, hey, this is how you get a consistent view even though you're reading directly from the store files. And then, that pipeline would be kind of your step into being able to do an analytical engine on, like, for say a Spark or something like that. As far as whether you specialize on schemas and stuff like that, I don't think there'll be a choice. I think that's, when you look at, like, Todd contributing Kudu, that's what it is. It's a schema, key value store concept. But you realize, like, that's where everything happens, right? I mean, no, well, it's a column. So if you look at Kudu, it's something, it's basically, it's what happens if you took a key value store and say, look, I'm going to apply a schema. So what does that mean? That means all of a sudden you have a columnar store. And that's what I'm suggesting for HBase, is that you allow it to provide a schema. And when you provide a schema, you get a columnar store underneath in the data blocks. It's how you're going to become performant for analytical queries. It's how you get better compression characteristics. This isn't new. That's like in my talk, I showed RESI, which is what Google's doing for Spanner. It's really about at that data block level, going to basically column minor and getting those vectorization characteristics that you like. I think HBase will have to do that to remain pertinent, because there's just not enough people just throwing. I mean, right now everybody throws bytes in, but I think once people get more and more sophisticated of, well, why does my analytical queries take forever? Why is compaction so slow? Those sorts of things. They'll realize, well, this is something that I'll have to move on.
All right. Thank you, panelists. I want to wrap it up there. Head downstairs or wherever you all need to go. Give them. Thank you for answering our questions. Josh, do you have any closing remarks that you want to make?
No worries. Thank you all for who have come out today and really been a part of this entire event. Again, I can't thank everybody who's participated up here on the stage. You guys have really made this event, and all of you in the audience again as well. There will be a questionnaire which will be sent to the email address you used to register. So please, if there's anything at all you'd like us to know, good or bad, our hope is really here to keep making HBaseCon as well as PhoenixCon a recurring event. So we'll be doing everything we can to see you again in 2019. And thank you once again. Just thank you.